Okay, so for question one says, how many different ways are there to order 9 distinct objects? What does distinct mean? Different, so you can actually distinguish between them. Okay, they don't look the same. Okay, so how many different ways are there to order 9 distinct objects? Can you say a bit louder, sorry? 880, cool. So 9 factorial. You happy? 9 factorial, okay? Question 2 then says, how many permutations exist of the letters A, B, C, D? So it should be 4 factorial, which is 24. Good, okay? And then for question 3, okay, how many arrangements of a ruler, pencil, pen, eraser, sharpener, and compass exist? Good, so it's going to be 6 factorial, which is 720, is it? Yeah? Happy? Good, okay. You notice the language which is being used. Okay, you notice the language which is being used. First question is talking about an order. Second question is talking about a permutation. Third question is talking about arrangements. Are you happy? I'm literally just asking the same question 3 different times, just with different numbers. Yeah? You happy with that? So just be aware of the different language which could be used. Okay, good. So in the first hour, we looked at this idea of ordering things, okay? So ordering, permutations, arrangements, it all means the same thing. And if we have n objects, the number of ways to arrange those n objects would be n factorial, where we just multiply by the successive numbers all the way down to 1, okay? So for example, if I had 6 things in a line, how many different ways are there of arranging them? It would be 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, okay? Now, here's my question. So we've got this idea kind of in our heads, right? Now let's suppose I have these 4 letters, so C, O, O, and K, okay? How many different ways are there to arrange those 4 letters? What do we reckon? So, well, look, one way you could look at this is saying, look, there's 4 letters, okay? So surely it should just be 4 factorial different ways. What do we reckon? Good, so we've got a problem here. Because we've got 2 letters which are the same, the 2 O's, okay, surely if we do like 1 arrangement, so this could be 1 arrangement, C, O, 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 K, then if we flip the 2 O's around, are you happy that it would look exactly the same? So I can illustrate on the screen here, okay, so surely 4 letters means 4 factorial, okay, but what if we flip those 2 letters around? Do you see any change? No. So in other words, we need to think here. It's not going to be 4 factorial because every single one of these arrangements, by the way, what is 4 factorial? 24, okay? So 4 factorial, 4 times 3 times 2 times 1, it's 4 factorial, 24. There's not going to be 24 different arrangements anymore because if we flip those 2 letters around, the 2 O's around, we'll get exactly the same arrangement. Are you happy? So what we need to do is, first of all, consider how many different arrangements there are with 4 factorial permutations. So I've drawn them on the screen here, okay? So can you see these are all the different possible permutations that I can have, okay? All the different permutations that I can have. However, you notice the way that I've put it here, so look at the first row, for example. On the left, I've got the 2 O's that way round, but then on the right, I've flipped the 2 O's around. Can you see there's no difference? There's no difference between the first column and the second column. Because the second column is just simply where I flip those 2 O's around. So how can I correct for this? How can I correct for the fact that we have repeated arrangements? Because if I flip those 2 O's around, I get the same thing back. Divide by? Good. So what I would have to do is divide by 2 factorial. Yeah? Why would I have to divide by 2 factorial? It is double, but why is it double? So think about what I started with. I start off with this. And then I said I can't distinguish when I flip those two O's around. So if I flip those two O's around, I can't distinguish. So why am I dividing by 2 factorial?
There will be duplicate outcomes.
Good. So in other words, how many different ways are there of arranging those two O's? 2 factorial. Yeah? Are you happy with that? So in other words, I need to divide by the number of sub-arrangements. Yeah? So for every single one of these ways, for every single 4 factorial ways there are of arranging these 4 letters, I'll have a sub-arrangement of 2 factorial where I can't distinguish. So I need to get rid of those. And of course, this is just basically multiplication. So to get rid of them, I'd have to do a division. Okay? Hence, how many different distinguishable arrangements are there? 12. Yeah? 12. Is that okay with everyone? So the reason why I'm dividing by this 2 factorial is because there are 2 factorial like sub-arrangements buried within all of these 24 arrangements. Is that okay?
Even if there were 5 letters, it would still be 2.
Depends how many duplicates there are, right? So if there were 3 duplicates, so let's say, for example, I had this, O-O-O-K now, right? 4 letters means 4 factorial, but what would I have to divide by now? 3 factorial, because there's 3 sub-arrangements which I can't, 3 factorial sub-arrangements which I can't distinguish. Because there's 3 factorial ways of arranging the duplicate letters. Does that make sense? Yeah? So in other words, however many duplicate letters I have, I need to divide by that because I can't distinguish those arrangements. Okay? Good. So there you go. Okay? So can you have a go at these 3 questions on the board for me?